Okay, we will continue with the Donate the Yellow Snow game series. If this is your first video, this is going to be episode number 10. So we will be using the code. If you can get the code by cloning the GitHub repository for programming Rainbow, Yellow Snow, C SDL2, and we will be working in the source folder directory. But we're going to be starting with the code that we finished with in video 9. So if you just delete the source directory and rename this one source, or copy in the source files to this, that will get you to where we are right now in this series. Okay, so the last video we spent a whole bunch of time setting up our FPS delay and our FPS counter, but we didn't actually get to use it for delta time. So I'll show you that real quick. Our target FPS is still at 6,000, and I am recording this at 30 frames a second, so you might not see how fast things move on the screen. My actual screen refreshes at 50 times a second, I believe, but the game is refreshing at 5 to 6,000 times. So let's show that real quick. So the yellow flake has already come down and hit me like immediately. If I press it again, it happens very fast. And if I hit F, the frame rate, I asked it to run at 6,000, but it looks like it's running about 5,000 FPS. So we need the flakes and the snowman itself to actually act the way it should, no matter what the frame rate is. So that's what we'll be working on today. Now I'm going to set this back to 60 for the time being, but we will change it again later. 60 FPS is pretty good. That's kind of like standard game speed that things run. So we are going to be working with delta time today. So we're going to add delta time to our game.h, and it's a float. So we'll just do, or sorry, it's a float, it's a double. And we'll just call it delta time. Okay, that will give us our access to that variable. And just looking here, that looks fine. Okay, and this, some of these up here, like this FPS up here, doesn't need to be here. Okay, so we're going to have access now to this this delta time. The way we'll set it is that's actually being returned from the function that we created last video. This FPS update, this handles calculating how much delay we want to happen, how much time has already passed, how much delay we need to delay the game to get it on target, and then also how much it was off to pull into the next frame and to try to make sure that thing is on. But it also handles showing us FPS. It does a frame counter in it, and it also returns a double that is the actual time that has elapsed during that frame. So that is our delta time. So we can go G delta time equals. So we can let this thing, and this is going to give us the last frame, what time occurred. So when we go back into the new frame, we'll have this time of how long the last frame was, whether it was 13 milliseconds or 14, or if we put it at 120, it might be at 7 or 8 or something like that. Or if we put it at 30, it might be 30 frames per second. It might be like 32 or 33, 34, who knows. So this delta time is going to be the time that has passed in the last frame. Okay, now we can use this for our movement. So we're going to need to change some stuff. If we look at our prototype for our header file for our player and the header file for flakes, the update on both of these, we need to add in delta time. So here it is, flakes update, and we want to pass in delta time as well. So we can just say double, we can call it dt. Okay, so we're going to add that, and we need to add it to player as well. It's a double and a dt. Okay, now we need to go into the actual player source, and it's not going to be happy because we have this new, we need to be passing in delta time here. Okay, so what we're going to do is we're going to say this is going to be double dt. Okay, so what's happening now is in the past we were moving, basically we were setting it to 60 frames a second, and we were moving it by speed. So every frame it would move how many, and that was 5. So now we have to think about moving things in seconds. So if we were moving at 5 frames every 5 pixels every frame before, and we were running 60 frames a second, that's 300. That's 300 frames of movement in 1 second. So now let us start thinking about movement in seconds. So speed should be our target in seconds that we want it to move, and we're going to multiply it by delta time, which is how much of a second has elapsed in the last frame. So we'll say speed times dt. Okay. I think it's just there for the, yeah. So speed times dt. Now, this is going to be a problem because our speed is 5, but that was not for how much we need to go per second. That was how much we needed to move per frame. So now we're thinking about in seconds. So like I said, that was equivalent to 300 pixels a second. So let's put 300 in here now. So we have 300 per second, and down here we're saying, hey, I want that 300, but I want to multiply it by delta time, which is however amount of a second. So if it was 1/60th of a second, I'm going to get 300 times 1/60th. I'm going to end up with 5, right? But if it was running at 30 frames a second for the last frame, then I'm going to get 10, not 5. So this is not only going to allow us to set whatever frame rate we want, it will also allow for hardware that can't maintain a frame rate to still maintain a continuous speed of movement. So let's say you had like a Raspberry Pi 1, generation 1, that doesn't have very much power, and it's just able to boot up a desktop, and then you run this, you might not get 60 frames out of it. But if you get 20, 30, 40, and it's jumping all over the place, your game will still kind of look okay. It should still move correctly. If your frame rate drops too much, obviously you're going to have, like 10 frames, 20 frames a second. You're going to really see it, but it's going to be moving at the correct speed, but it'll just be choppy because of the fact that the frame rate is so low. So that's what we need for the player. So let's go do the flakes as well. The flake source code. Where is it? Flakes here. And we need to update the update function right here. So this is double dt, and the exact same thing is going to happen here, where we have the speed is happening. It's going to be speed times dt, and this speed needs to again be represented in seconds, not, and that's still the same, so it's 300. Okay, so we've passed in the delta time for the flake, we've passed in the delta time for the player, we are getting the delta time and holding it in the game, we are passing those around. So let's see if everything is working as expected. Okay, what do we got going on here? Okay, so we have a conversion. This is because I have very strict compiler rules, so this needs to be a so what's going to be the problem here with the setup that we currently have? I could cast this, which is just fine, But what happens if, say, we need to move half a pixel? What if our frame rate is so high that we need to move half a pixel? Well, when we cast it to an int, it's going to be 0. And it'll just always be 0, so it'll never move. And we're always using the rect y, which is an int, and we try to update it with half a pixel, that gets cast to 0 the next frame, half a pixel again, half a pixel. So maybe the frame rate's really high, and so it's moving at small increments, but the problem is it keeps getting truncated. So it's never going to move. So what we really need to do is we need to hold on to the movement in a double and cast it to the rect, but actually update the double. So let's set that up. So we're in flakes. Let's go here to flake H. Okay, so like again, we need to hold it's going to be the Y position as a double. And this is just kind of, so we can have a highly accurate version. So imagine we're holding it as a double. We move half a pixel, right? So the double's holding that half. The half gets cast to a 0. So it gets drawn in the same spot. But the next frame, that double that's holding half a pixel gets incremented again by a half. Now it turns into 1, and it gets cast to the int to draw, and it is a 1 now. And then the next frame, it's another half, so it's 1.5. That still gets cast to a 1. We got a 1, and the frame after that, and now it's a 2. Do you see? So if we're holding it in the double, we still are, even though we don't have the precision of half of a pixel to show it, we are still keeping track of the actual position. So double, we'll call this pause y. So position y for the flakes, we don't really need, we don't need an x because we're not updating the x position. We're just updating the y. Okay, so if we do that, and then we go into the source, okay, we have to think about this a little bit now. We have our reset for our flake, where we're setting the y. Okay, so when we set the y here on our reset, we need to now also set the position, because we're going to be using pause y for the real position. So right here, when we set it, we need to set them both. So we can say f pause y equals f rect dot y. And we probably have to cast this to a double. That's just so wherever we set the flake at, now we actually, they're both there, the physical flake being drawn there, but the thing that we really want to hold on to, that position y as a double, it is also set to that exact same position now. Okay, so now we have that. What we'll do is, instead of updating rect y, we're not going to do that. We're going to update, we do no matter what, we need to update pause y, and this will be plus, it's the same, so we could have just made this. Okay, so we're updating position y with the speed and the delta, and this is a all double. That's a double. Speed should be a double. We need to change that. I know it's an int because initially I'd set it up as an int, but it does need to be a double. Where is that speed? Double. Okay. We're probably going to get a bunch of complaints about this, and we're going to have to work through them. So flake C, there we go. Okay, so where's update for flakes? Flakes free, flakes reset. So we're updating in position y. We got our speed, we got our dt. These are all doubles. Okay. Now we need to see if this double is breached the ground, right? So we're going to check that. So we're going to do the pause y. And I believe we need to cast this to an int for this to work. Or the ground, we could just put the ground as a double. Yeah, there's no reason that the ground can't be a double too. Because we're only using it that one time. Where's ground? Okay. Okay, so now we're back in the wrong spot. So we're seeing if the position y is bigger than the ground. If it is, we're resetting the flake. Okay? But if it's not, we're going to update our actual rect this time. So we're going to cast it. Sorry. X rect dot y equals, and we need to cast this. And this is going to be f pause y. Okay. So we are updating. We are checking if we hit the ground. If we are, we are resetting. If not, we still have our accurate position, but now we're casting it. And then we're going to the next flake. So we're doing all the flakes that way. I want to test this, but I know it's going to complain about player as well. Well, let's see if it doesn't complain about this one and it just complains about player. That will, oh. So I'm just going to run the compiler. I expect it won't compile. I expect it's going to complain about player. If it does, I'm happy. If it complains about flake, then we need to work through why it's complaining about flake. Okay. Where is it? Player update. Okay, that's totally fine. We forgot to pass the DT into the game. So I'll just do that real quick. That's a minor thing right here. We need to pass in the delta time. So this is G delta time on both of them. All right, that clears that up. Now let's see what else we got going on. Okay, so are we in player here? We are in player. Okay, so it's not complaining about this. I'm just gonna let it do the thing. I know it's not right, but I just want to see it compile. So I'm gonna just I'm going to cast it to an int, just so I can see the flakes moving. And it should look fine for this, but if we set the frame rate really high or something, it just won't be accurate, is what I mean. So we will fix that, but I just want to see it compile. I want to know if I did the flakes correctly. So player and update. Okay. So this is a double, and speed hopefully is a double. Let's check. I'm going to make this a double. And then I can just cast the answer of both of them. I'm just going to cast these two together as an int. And we will fix this later. Okay, so let's see if we can compile. All right. Int. What line is this? 64. Wait, where? I got two spots on this one? Hold on. Where did I change this? 64. Oh, I see. Yeah, okay. And I didn't realize this. I need to do this one too. Like I said, I just want to see the flakes working right now. Yeah, we've already fixed the speed, I believe. Okay, okay. My player, we didn't fix the speed for the player. Oh, do you see what it's doing? The flakes work fine, but the player doesn't. But that's fine. That's totally fine as long as the flakes are working good. Okay, so let's check the speed up here. We do have 300, which is fine. But we have that same problem. So we need to make an X position, just like we did with the flakes Y position. So player H, we have a double here. Let's just right here make a double pause X. Okay, double pause X, and then on the reset, we're going to do the exact same thing. I'm going to set the P pause X equals, and I'm going to cast the P rect to it. Yeah, double. That's fine. Okay, so whatever we set the rect to, then I'm going to set the double to. Now that that is set, we do have speed at 300. So now when we go through and we go to update, we need to be updating the other one. And we're still checking. The check is going to become more interesting here. So in here, we are going to use the, not the rect, but the X pause X, and not worry about casting it. So that updates that. And then we are going to check the X pause. So we're not going to set the rect. These are going to be the X, the position X. That's a double. And then at the end of that, we will cast it to an int for the rect X. But we don't need to cast it right away. We can cast it after both of these checks, really. So we could say, I'm going to go back to the other one in a second here. We can say p rect dot x and equals int, and this one will be p pause x. Okay, so up here on this one, we need to do the same thing. Pause x. I'm going to get rid of this. And then this one the same. We're checking the position x against the rect width and the, or I mean with the rect against the window width, yes. Okay. Okay, so we got that, and then at the end we set it. Yeah. Let's just see what it complains about where we're at. Oh, we're moving correctly. Okay, well now let's see if it operates at different speeds. So let's go to the main H, or let's close this. And let's try 600, because that's fast, but it's about 10 times as fast. So we'll know if something's not moving correctly. Oh, I need to recompile because when I change main H, that's not going to rebuild everything. It's not going to rebuild the stuff that needs to be rebuilt. Okay, I'm still moving at the same speed. Let's check the F. Okay, 600. Yeah, it looks pretty good. That's pretty good. Okay. Let's try, say, like 20. Let's try the other side. Like if you had your game running really slow, rebuilding the whole thing. Okay. Everything's still moving at the same speed, but it looks a little bit like a slideshow because I'm only getting 20 FPS. And if I press F, there's the 20. Okay. Let's see if we put it a little bit more extreme. Try 5,000. I don't think it'll go to 6, but might get up like 4.8 or something like that. Okay. Now, to be fair, my screen is not refreshing this fast, but the game is. My screen can only show what's being displayed at the time, and you're watching it at 30 FPS. So, but the game is running at 4800, 4700. It is running that speed, and it is drawing all the stuff to the render at that speed, and the movement is still smooth. So that is a win, I think. Okay, so we didn't need to cast. I'm just wondering about the flakes real quick. Did I do some needless casting then? No, the ground, it doesn't matter, I guess, what the ground was. We're only casting there once. So, okay, so now we got this movement down. Let's shift gears. Let's get some music. So we already have the sound library set up for everything, and we're loading sound effects. So it's just a tiny step. We just need to load the music file to play music. So the music that we're using is right here, and it's just called Winter Loop. It's an OGG file as well. And we've already initialized everything that we need for SDL with the music stuff. So what we just need to do is get into load media. And we need to use this function that mix load muse. Mix load muse returns a mix music, not a chunk, but a music. And it's going to be the same thing. It is heap allocated. It's a pointer, so we're going to check that pointer, and we just need the name of the file. So I can just grab one of these right here, and yeah, I'll just copy that. And it's instead of wave, it's muse. So we'll call this music. Muse, and this is in music folder, and it's called Winter Loop. Okay, and it's just music. This is going to complain because this doesn't exist yet, so we're going to do that. We're loading music. We got the mix get error, and that's good. So that's going to load our music up. Like I said, it'll probably complain right now because, yeah, it doesn't exist, the member. So we need to get into game H, and we need to make that member exist. So this is a mix music, and it's called music, I guess. Okay, so let's go check out that it's not complaining there in load media anymore. Okay, now we need to clean up the music. So that is in game C. Now I want to halt the music before, just like I halted the channels, I want to halt the music before I clean it up. So here is mix free music. This is what the function we're going to use to free the music. But before that, we are going to halt the music. Where is that? So this is mix halt music, and it's going to return 0 regardless of what any music. Okay, whatever. I'm not going to worry about the return. I'm just going to call the halt on it. So I'm going to halt the music, and I'm going to free the music. Let's see, where was it? Over here somewhere. Free the music. So halt the music and then free the music. Yeah, those two. So that's going to be right here. So we got mix, halt, music, then mix, free music. And we have to pass in the music that we're freeing. And we'll nullify the pointer. Music equals null. Okay. So that is taking care of the unloading of the music, or if there's any music playing. Okay, so we've loaded the music. We are unloading the music. The now playing of the music, we can check to see if that failed or not. So let's go look at that real quick. So we loaded, we freed, we halted. So playing music. Okay, so this takes in the music, and this asks how many times you want it to loop. We are going to tell it to loop infinitely, so I believe we set it to -1, the number of loops to play the music. 0 means play once and stop. So I believe if we set this to -1, it just plays indefinitely. I don't see it saying anything about it here, but I'm pretty sure that is the case. So there's our music, that's our function. And we are going to check if this fails. Return 0 on success or fail. So what we're going to do is we're going to call this right before entering the main game loop. Okay? We'll just grab that. So this is in right before our main game while loop right here. I'm going to say if, and then put that function in. And this is going to be G, music. Yes, yes, I know too many. We need a -1 on this. Okay, so in load, I'll just grab it from there. Right here, this guy. So right here. Now we have error playing music. Okay, so I'm checking if that failed or not. Okay, so this should start up the music, but I want to be able to pause the music too. So we can check to see if the music's paused, or we'll check to see if the music's already paused. If it isn't paused, we'll pause it. If it is paused, we'll resume it. So yeah, we'll just make a little function here in it'll just be local. So we'll say this can let's check to see about the pausing. So the pausing and the resuming, yeah, I'm not going to be checking this. So this is going to be a void function. Pause music. This is going to be, yeah, I can just make it. So we'll have this void function, and I'll just set it up down there. New game reset. I'll just make it right here. So what we're going to do, like I said, we're going to check if it's paused. So music pause. Nope, that's not the one. Music paused. So this guy is going to return true if it is paused. So if the music is paused, if it's paused, we want to resume it. Resume music. Yeah. And otherwise, we want to pause it. I'm just going to use this one and change it. Pause music. I believe that's the function name. Okay, so if it's paused, we resume, else we pause. And I don't think we need this right here at all, because we don't need to send the name of the music in. We'll just fix the prototype above. And then in our right down here in our events, we can just put another case right here. We say SDL, and we can say P, sure. And we'll just call that, what do we call it, pause music. Okay, let's see if that works. Okay, so hopefully the music will start playing automatically because we are doing it here. And then if we press P, we can pause the music and then we can resume the music. So we're not stopping the music and we're not restarting it. We're pausing it and we're resuming it, which are different. It's going to be in the same spot, basically. I'm going to rebuild it. And function declared isn't a prototype. Void. Game 9. Function declaration isn't a prototype. Prototypes. Old style definition, okay. I'm just wondering if I need to put void in here. And in the actual function definition, where is that? Do I need that like that? Okay. Okay, I'm just going to press P. Okay, unpress P. Okay, that seems to work. I hear all the sound delayed, so I have to wait an extra second to hear whether it happened or not. So the reason why I paused earlier is because I was thinking about the fact that I actually want the music to stop playing altogether when the game is over, when you've hit a yellow flake. So then I'm thinking about this whole paused music and resume music might not do anything. So I think I need to throw another check on the outside of all of this to see if music is playing. But yeah. So right here we're playing the music, but I want to halt the music if, where's our collision? Play channel, hit. Right here, I actually want to halt the music. So we say that's a mix, halt music. We've already seen this function. Okay, that's going to halt the music, and then I want to do this right here. Grab this, and I want to, when we do the reset of the game, right here, I want to restart the music. Now, I don't know if this is going to affect the whole pausing thing at all. So let's find that out real quick. Okay, I'm going to hit yellow. Okay, now I'm pressing space. Okay, I'm going to pause it. So the space turns the music on again. So that's a bit strange. Basically, the pause works, but when I reset the game, the music starts playing again. And I'm wondering if instead of stopping the music, I should pause the music when I need a flag basically to know if I want the music, because I imagine if somebody's playing this game, they may not want to listen to the music. So if they don't want to listen to the music, and they pause it, but then the game ends and they restart the game, the music starts again, and that could be annoying. So maybe I need to hold a boolean that basically holds the intent of the player that they want it paused. I think that would be good. And maybe instead of stopping and restarting the music, we just pause it. Or if the music has been paused, let's set the boolean up. So this is not something I had thought about ahead of time. I wasn't going to have this pause in here. It would just start and stop when the game ended. But let's see if we can implement this. So on game H, let's put a bool pause music. So we'll call this pause music, and this will be set false by default. Okay, so when we pause the music, we'll set it to true, and when we unpause the music, it'll be set to false. When the game wants to pause the music, it won't pause the music. It will always pause the music when the when you've ended the game. But when you restart the game, it will look to see, should I restart the music? If you have this pause flag set, it's not going to unpause it. So in the game, when we choose to pause the music right here, we should we should only be doing this if the game is playing. So we do need to put game in here now. Game G, okay. Put it up here. Struct game G. Yeah. Okay, so now we have everything we need. So we what we want to know is if the person has set the boolean or not. If G pause music, so if we've asked it to pause the music, we are gonna unask it. Pause music to equals false. I'm just gonna get this out of the way. The intent of the player. else music equals true. Okay, so that's the intent. So right here, we want to resume the music. So if G playing, then we are going to resume. Resume music. Okay. Okay, so that means if paused, if we were paused and we hit the button, now we want to unpause it. We want to set our flag to false. If we are playing, we want the music to resume. If we're not playing, we don't want it to resume. Else, if it is what was not paused, we want to pause it, and we want to pause the music. We don't even need to check anything. We can just tell the music to pause. So we can just grab this from here. Now we have the intent of the player. So when we're checking it in the collision, we can do the same thing. And the reset. Sorry, the collision can always just pause it, but the reset can unpause it only if both conditions are true. So where's the reset? Handle collisions. So the reset. So we're not going to do play the music. We're not going to do that. What we're going to do is we're going to say if and we're going to say music pause music. Okay, that means they want it paused. So if the player doesn't want the music paused, then we can resume the music. And we don't need to do anything else there. For the collision, we just need the music to pause. We don't need this halt. Not the play channel, this one right here. We just need, come on now. We just need to pause it no matter what, because it doesn't matter if the person wants the music playing or not. You've hit the yellow thing. Pause music. Okay. So on the flake hit, we pause the music no matter what. On the reset, we resume the music if the player doesn't mind. On the player asking to pause the music, if it's already paused, they're unpausing it. That unpause only happens if we're in a playing state. The pausing happens no matter what, and we're setting our Boolean on both of those to the ones we want. So let's give that a test. So if I pause the music, it should not come back if the game is playing. Okay, that's not right. Pause music to few arguments. Yes. So we need to pass in right here. It's just G, right? Okay, I'm going to pause the music. Okay. And now I'm resetting the game. Cool. So I'm going to unpause it now when the game is finished. So it's unpaused. I don't hear any music. So I'm going to resume the game. I should hear music, yes. Okay. restart it again. Okay. So we're not using the halts anymore, except for the cleanup code. So yeah, I hope that makes sense here. What I've worked through here is we're just holding Boolean in game H, and this is, like I said, the intent of the player. If they don't want to listen to the music, we're just going to leave it off. And then on the game, we're letting the player choose to pause it with the P button. It's calling this function, and it's pausing the music no matter what, but it's setting the boolean to true, so we know the intent. If it's unpausing, it's setting the boolean no matter what, but it's only resuming the music if it's in a if the game is in a playing state. Okay, and up here we are only checking the failure right here when we initially start playing the music before the game loop. We play it there, and we're unloading the music. The game, oh, it's still in game, sorry. Up here when we're cleaning up, we're halting the music, we're freeing the music, we're nullifying the pointer. Okay, and we loaded the music in load media down here. And now we're just using the halt, and we can check to see if it's paused already. I don't think we actually used the check to see if it's paused. We just told it to pause. Let's check that one more time. Maybe we are. We're checking. Oh, yeah, we're not toggling it on whether the music is paused or not. We're toggling it on what our flag is set to, what our Boolean flag. Okay, so that is, we got delta time now. We have music now. That's basically the entire game. We can add little extra things like a splash screen or a title screen or something like that. I may do that in the future, but at least now you have a fully working game. It's got delta time. It has variable frame rate. It can handle if your hardware can't keep a frame. It's got music. It's got sound effects. It's got collisions, box collision, simple box collision, all the movement. So all the basic parts you need to make a game. You can take this and you can make other games with it. Do all kinds of other stuff with all these basic kind of tools that we've been building up with this game. So I hope you enjoyed, and thanks for watching. Bye.